Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No. We've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Dr. A, and welcome everybody to Wednesday night math night. Man, oh man, these dark circles are really showing that it is testing season in the elementary schools right now. But that said, I am so happy to be here with you guys. I love doing Wednesday night math sessions with you. And we are going to just have some fun going over some math problems. Like Dr. A said, if you have any questions, don't hesitate to drop those questions in the comment box. I love interacting with you guys when we are solving math problems. So drop those comments in the comment box. I would be happy to answer any questions that you might have. Also, we will be going over about 10 problems, and those problems do run from kindergarten through 12th grade. We are doing a little bit of a focus on geometry, probability, and statistics tonight because those seem to be hot topics for everybody. And the statistics is kind of an interesting one. It's something we haven't hit on before, so I'm excited. If you have questions throughout the week, and you're like, man, I really wish I could get a hold of her because I was studying this question and I'd like for Amy to go over it next week on Wednesday night math night. You can always email me at more_Amy@hotmail.com. And I will absolutely be sure to include any questions that you might have in the upcoming weeks. Hey, Susanna, there's my email. That's where I got the idea from. Hi, Hope. Hi, Milagros. It is so good to see you back. I'm glad you're back from the cruise. Man, I would love to go on a cruise right now. What grade level is GKT math? That's an excellent question. So a lot of us are taking subject area exams, which means we're taking K through 6, 4th, 5th through 9th, 6th through 12. However, the GKT math in the state of Florida is grades approximately 4th through 8th grade. With a touch of 9th grade sometimes. But when you truly look at the blueprint that's provided by the state, we are looking at 4th through 8th grade math around there. Hi, David. Good to see you. Hi, Joseph. Good to see you. So before we get started, I always like to start with an introduction. So where are you from? What test are you prepping for? That helps me guide our sidebar conversations because all the problems I choose, I usually like to, when I write them, I usually like to make sure that it's a good problem for everybody. And our get to know you question tonight, because I love to get to know who's in the room, is and I'll steal it from Milagros. Do you enjoy cruising? Or are you a land vacation type of person? Are you a cruising kind of person or are you a land vacation type of person? We love to cruise, but that's pretty much the only time you will find me at the beach. So we love cruising, not because of the beach, but just because of the aspect of cruising and all the food is included and we like the activities and all of that. But then we prefer the mountains. So if you could cruise through the mountains and go skiing, that would be our kind of vacation. But we do love cruising, absolutely. So where are you from? What test are you prepping for? And are you a cruising kind of vacation or a land vacation kind of person? So without further ado, let's go ahead and get started with our first problem. Ooh, this problem I promised you that we would do tonight. So let's go ahead and explore this problem. If 3x plus 5y plus 7z equals 49, and 9x plus 8y plus 21z equals 126, what is the value of y? What is the value of y? Now, typically when we see equations with two variables, we'll start with two variables. Usually we're looking at elimination or substitution. So that said, when we're looking at something with three variables, we're also going to look at using either elimination or substitution. Substitution is going to be really hard in this case because we don't have any variables that are isolated already. So we would really have to isolate a variable and then plug it in, and then you're still going to be left with two variables. So if we had, this is a big if, it has nothing to do with this problem. If we had 3x plus 2y equals 7 and we had 4x minus 5y equals 9, we could eliminate one of the variables by multiplying, and then if we get rid of the variable, then we would only have one variable left. But theoretically, if we eliminate a variable when we have three variables, then we're still going to have two variables left. It's going to make it difficult to figure out what the value of one of those variables is. So that said, that's where I'm going to start. I'm going to try to eliminate one variable. So let's go ahead and try that. I have 3x plus 5y plus 7z equals 49. And I have 9x plus 8y plus 21z equals 49. Now, I'm going to try to multiply one of these equations by a value that's going to allow me to eliminate something. Am I going to want to eliminate the y value? Definitely not the variable I want to eliminate. Why not? Because we're trying to find y. Could I eliminate the y value? I could, but that's not going to help me because I'm trying to figure out what y is. So I'm going to try to eliminate x because I immediately see 3x and 9x. So if I multiply the top equation by a value of -3, what do I get? Let's distribute and find out. -3 times 3 is -9x. That was the goal. The goal was to get the same value but negative so that they would cancel out. Let's keep distributing. Minus 15y minus 21z equals 49 plus times 3, 147. Now I'm going to add these two equations up. 9 plus negative 9 is 0. That was the goal, to eliminate that variable. 8 plus negative 15 is negative 7y. 21 plus negative 21 is also 0. And now you see what happened. I was so stressed about having 3 variables, eliminating one of them and only having 2 variables, but I didn't need to stress out because it worked itself out, didn't it? Equals 147 plus 49. 196. So negative 7y equals oh goodness, I knew I did something wrong. So what did I do wrong? Well, I did 49 times 3 is 147, except I didn't bring this negative with me. So as soon as I saw that 147 plus 49 was 196, I knew that none of my answer choices was going to be correct, because 196 divided by negative 7 is not going to give me any of those answers. So already my brain was like, woo, 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 you did something wrong. So instead of 147, that should have been negative 147, which should give us closer to the right answer. So negative 147 plus 49 equals negative 98. And negative 98 divided by 7, negative 7, is negative 14, which I'm confident that's the answer. There's our answer. And it's not, goodness gracious, my brain is not working today. It's not a negative 14. It's a positive 14, because the negative divided by negative is a positive. Woo-wee! So what I did was I eliminated a variable by multiplying by a negative. Negative times a negative is a positive. Negative times a positive is a negative. But by distributing that, I got negative 9x minus 15y minus 21z equals negative 147. And then when I solved that, I got negative 98. And then when we divide by a negative, we get a positive. But the whole purpose of that problem was to show that we were stressed about eliminating one variable and only having 2 left over, but it eliminated both. All right, let's move on to problem number 2. Data is gathered over many years on the average number of trips a household makes to run errands per year. Data is collected beginning in 1986. And the equation f of x equals negative 2x squared plus 98x plus 340 models the average number of trips a household makes to run errands each year since 1986. In this situation, what is the value of the y-intercept and what does it represent? That was a lot of words. I'm going to read my answer choices, and then I'm going to go back to my problem to really process what that problem said. So, what is the value of the y-intercept, and what does it represent? Well, before I start looking at my answer choices, I know, and even though this looks like a high school problem, which it is, all of us need to know, K through 12, what an x-intercept and a y-intercept is. So I'm going to take this problem down to my elementary people, because my elementary people still need to understand coordinate grids, most of you. So if I create a coordinate grid and I have my x-axis and my y-axis, and I have a graph. It could be a line, it could be a parabola, it could be whatever. What are my x and my y intercepts? Well, my x-intercepts are going to be where my graph crosses the x-axis. So x-intercepts are where the graph crosses the x-axis. And the y-intercepts are where your graph, I'll give you one hint, crosses your y-axis. So my x-intercepts are where my graph crosses my x-axis. My y-intercepts are where my graph crosses my y-axis. So that said, what do I know about all x-intercepts no matter what? All x-intercepts are going to have a value of 0 for y because I'm moving over a certain number of values, then I'm going up or down. I'm not going up or down and then moving over. I have to get to the elevator before I can go up or down. So I know my x-intercept is going to have an x value and then 0. And I know that my y-intercepts are going to have a 0 for x because I was already at my elevator before I had to go up, comma y. So without even looking at my answer choices and really reading them through, I know if I'm looking for a y-intercept, A and C are out. Doing some preliminary elimination is really, really important, especially because the words that they put next to those are going to sound really, really convincing. They're going to make you think that that's what you should pick. So if you can eliminate because these are actually x-intercepts, then you don't even have to worry about the value or about the words, okay? So now, is it going to be 0, 340, or is it going to be 0, 98? Well, when I plug 0 into my equation, what do I get? Plus 98x plus 340. Negative 2 times 0 squared plus 98 times 0 plus 340. Anything times 0 is itself, or anything times 0 is 0. Anything times 1 is itself. So my y-intercept is 340, which is the number of trips a household makes in 1986. I was really hoping we were going to have a week like we did last week, where we did not disconnect, not even once, but we weren't so lucky. So here we are. It disconnected. We have to reconnect. So we'll take a water break. All right. Share screen. Okay, here we go. So we know that it is the number of trips a household makes. Why? Because let's go back to the words. It sounds super complicated, but the problem helps. So data is collected and the equation here models. This equation tells us the average number of trips a household makes. That's your f of x. Since 1986, that is your x. your time. Thank you, Joseph. That's a really good point. So I know that my y-intercept is going to be the average number of trips a household makes, not the number of years. Okay? So that's our answer. B is going to be our answer. David, what happened to the 126 in the second equation? It was incorrect because I did my math wrong and then I fixed it. That's all. All right, let's look at problem 3. All right, let me just start by saying these next few problems, there's probably like 3 or 4 that are all going to be Venn diagrams. These next few problems are all different kinds of Venn diagrams. Everybody needs to understand Venn diagrams and what they mean, but the notation is not necessarily required of everybody. So even though the notation might be not within your parameters, you still have to understand what these problems are asking, which is why I really like these problems. This technically does fall under statistics because we are looking at data representation. So it falls under data, statistics, probability, which usually are all somewhat in the same category when we're looking at our blueprints. So let's get started. Now, some of your exams have shifted to not being multiple choice, but to having a fill in the blank. So this problem is a fill in the blank problem. A Venn diagram is shown below. The universal set U contains 154 elements. There are 42 elements that do not belong to either set A or set B, but do belong to the universal set U. Set A contains 58 elements and set B contains 66 elements. How many elements are there in the set A upside down U B? And I said that for a reason. There is a proper terminology for that, and I will get to it. I said it upside down U because some of you are looking at me like I have 7 heads. And I know, I get that. I want us to break this down because I don't want you to get overwhelmed by a problem when really you probably know how to do it when it's just the language. So the universal set U, aka everything that falls in this box, contains 154 elements. You're probably like, listen, Amy, I am not taking a chemistry test. I'm taking a math test. Elements are just items or numbers or whatever you want to think of it as, pieces of data, okay? There are 42 elements that do not belong, 42 items, numbers, whatever, that do not belong in A or B, which is why they are on the outside, but they do fit in the U section. So if we think of these as just different buckets, A is a bucket of numbers, B is a bucket of numbers, U is a bucket of numbers. And the B bucket and the A bucket share some. And then there's U, which includes everything except there's 42 things that belong in U, but that don't belong in A and B. Hence why the 42 is on the inside and not the outside. So set A contains 58 elements. Set B contains 66 elements. So there's 58 inside of here. And I'm actually going to switch to my highlighter. There's 58 inside of here. And there's 66 inside of here. Make sense? How many are there in the intersection of A and B? Or is really what that says. The intersection of A, set A, and set B. Where is the intersection? Elementary people need to know this. Middle school people need to know this. High school people need to know this. The intersection is literally where those two circles are intersecting. If it said this, that would be the union of set A and set B, which would be everything. So if we're looking at the intersection, we're only looking at what they're sharing. If we're looking at the union, we're looking at everything included in A and B. So let's actually go to what this question is asking. How many total items are in the box? 154. How many are not in A or B? 42. So I'm going to get rid of those right away. So this is A and B. Or if we wanted to write it mathy, we could write that is the union of A and B. But we want to know the intersection. And you're like, Amy, that's so easy. You got 58 here, you got 68 here, just figure it out. Because 58 plus 66, if I pull out my handy dandy calculator, 58 plus 66 does not equal 112. So you're like, wait a minute, why is that? Here's why. Why does this equal 124, but this equal 112? Because remember, some of these are shared items. Some of these are shared elements. It is not 58, 66, and nothing. But think about this. When I take an element, so I'm going to redraw it up here. If I have A and B, and I have 58 and 66, that means there's nothing shared. But if they share one item, that means this is no longer a 58 and this is no longer a 66. Instead, this is a 57 and this is a 65, because 57 plus 1 is 58 and 65 plus 1 is 66. And we have to remember that set A only has 58 items and set B only has 66 items. So if what I actually have is 112 here, but this is showing 124, how do I get that to be different? Well, I need to figure out what that difference is. So 124 minus 112 is going to give me 12. So that right there tells me that instead of 58 and 66, they share 12 items, which means how many are left over here if the whole circle equals 58? Well, if the whole circle equals 58, then I'm going to have 46 over here, because 46 plus 12 is 58. And how many am I going to have over here? 66 minus 12 is 54. Now watch what happens. If I add 46 plus 12 plus 54, I get 112. So I'm not going to add 58 plus 66, because that shows how many elements are in A and B, but it includes the items that are shared. So how many items are in the intersection of A and B, which is just this section right here, 12. Is this part of GKT? I have not seen this notation as part of GKT, but could you see Venn diagrams? Yes. All right, more Venn diagram problems. The Venn diagram is shown below. The universal set consists of only A, B, and C. Now, before I get into the middle school and high school notation of this, I want everyone to just look at this Venn diagram, and I'm going to call out some random questions, and I want you to think about it, because I want to take this problem and really make it elementary for my elementary people. So, how many elements, items, whatever you want to call them, fall in exactly 2 categories? I'll give you a minute to think about that. How many elements fall in exactly 2 categories? Well, we have to think about where there are 2 categories. So if I take my basic colors, my primary colors, my red, yellow, and blue, A is going to be yellow, B is going to be blue, and C is going to be red. Where do I have an intersection of only 2 things? There are no intersection here, so those are not going to fall in that section. No intersection here, no intersection here. Where we do see the intersection is here. Which sections have exactly 2 categories? Here, here, and here. How many intersections does the 6 have? All 3. All 3 circles are intersecting at the 6. So how many elements? We only have 1, 2, 3 elements that fall in exactly 2 categories. How many elements total are represented by this data? How many elements total are represented by this data? I would just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, let's look at our actual problem. So that was just kind of like a side note. Which set represents the union of A and B? The union of set A and set B. The first thing I'm going to do is look at what the union of A and B is. A includes 1, 2, 3, 6, 9. B includes 1, 6, 7, 8, 12, and 18. The union of A and B includes everything listed in A and everything listed in B without repeating anything. So 1, 2, 3, 6, 7, 8, 9, 12, and 18. Really? It includes everything on this screen except for 15 and 4. Because those are the only two numbers that don't fall in either A or B, right? Now, we have to take what falls in A and B, but then take away anything that's in C. Well, we took away these because those don't exist in A and B anyways. But are there elements that exist in A and B that also exist in C? There are. All of these elements exist in C. So I have to take out 6, 9, and 18. So my answer is 1, 2, 3, 7, 8, and 12. 1, 2, 3, 7, 8, and 12. And I had a typo. I accidentally deleted the 1 out of C. 1, 2, 3, 7, 8, and 12. Now, I have a question for you. I want you to take what you learned about the intersection of, and I want you to apply it to this problem. Which of the following, so it's the exact same set of data. So I'm not going to go over what we're looking at, what kind of data we're looking at, none of that. Let's look at the question. Which of the following represents the intersection of set A and set B minus C? We're going to start by looking at just the intersection of set A and set B. What is the intersection of set A and set B? Just where A and B intersect. That is the only place that A and B intersect. That's it. So if it said, what is the intersection of set A and set B, and that's it, we would be writing 1, 6. But then we still have to take out the elements that are in C. Which element is in C? Six. So what am I left with? Just 1. So we were on a roll. We were doing so well connected, and then it disappeared. So in this case, our answer is just going to be 1. It's not going to be anything else. Does that make sense? All right, let's keep moving when my iPad decides to connect. I hope y'all are having a good week. It's a pretty good week over here. So I hope you're having a good week too. Random, Wednesday thoughts. All right. So the answer is just going to be E, because we have to get rid of that 6 value if we're going to subtract C. Right? All right. This is a totally different set. It looks the same, but it's different numbers. So this is really, so these two were really for my middle school and high school people. This one breaks it down for my elementary people. So the Venn diagram is shown below, which represents a set of numbers. Which of the following represents the rule for the set of data represented by set A. So coming up with rules for our data is important because then we could think of other elements that could belong. So set A. I'm going to trace that circle and then color it in so I know what numbers I'm dealing with in set A. I am not going to try to think of a rule on my own. I'm going to look at the answer choices and see if they match. Unless it's a fill in the blank, I'm not going to sit here and stare at it and think, gosh, I can't think of a rule. That's why they give you your answer choices. So I'm going to start from the bottom up just for kicks and giggles. 2-digit numbers. Are all of the numbers in A 2-digit numbers? I don't want to know if there are 2-digit numbers in set A. I want to know, do all of the numbers match that rule? 2-digit numbers? No way, Jose. 2 is not a 2-digit number. 8 is not a 2-digit number. 4 is not a 2-digit number. Numbers that are multiples of 3. Is 4 a multiple of 3? What is a multiple? If you don't know what a multiple is, that's your first problem, right? Okay. This is getting on my nerves today. 4 is not a multiple of 3. A multiple is a number that is like, can be divided by the other number. So like 6, 9, 12, 15, 18, 21, 24, 27, 30. Those are all multiples of 3 because it's 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5. Those are all multiples of 3. 4 is not a multiple of 3 because 3 times nothing gets me 4. 4 is a multiple of 4. 4 is also a multiple of 2. So that said, those are not multiples of 3, right? Let's look at the next rule that is being shared. Odd numbers. 2, 4, 8, 84, 26. Are those odd numbers? Nope. As a matter of fact, they're even numbers. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. And really, the number 6 should belong right here because 6 is an even number that is also a multiple of 3. So if we look at the rule for set B, these are all multiples of 3. And what is the rule for C? 2-digit numbers. So 84 is a 2-digit number, a multiple of 3, and an even number, which is why it falls under all 3 of those circles, right? 31 is not an even number, A. It's not a multiple of 3, but it is a 2-digit number, which is why it's just in circle C. So understanding those rules is really important. So elementary people, you being able to recognize that rule is really critical. Let's go ahead and look at problem 6B. Another Venn diagram is shown below, which represents a set of numbers. How many numbers in the set shown below are 2-digit numbers that are divisible by 3? How many numbers in the set below are two-digit numbers that are divisible by 3? And I'm just moving the 6 into the correct category before we keep moving on. So here's where I'm going to think. Two-digit number. Only going to be these numbers right here, right? Two-digit numbers. Check. That are divisible by 3. Well, if it meets 2 criteria, it is likely going to fall in an intersection, right? That symbol that we learned earlier today. So it's not going to be 31. It's not going to be 29 because those don't fall in an intersection. 26. What if you don't know your multiple? Like, what if it was like 473? How would you know if it's a multiple of 3? Here's a little trick, because I use this little rule or this little trick to this day. If you add up the digits of the number, so 26, what if I didn't know if it was divisible by 3 or not? 2 plus 6 is 8. Is 8 divisible by 3? No. So 26 is not divisible by 3. Let me give you a harder one. 3,271. Is that divisible by 3? Well, 3 plus 2 plus 7 plus 1. 3 plus 2 is 5. 5 plus 7 is 12. 12 plus 1 is 13. 13 is not divisible by 3. So 3,271 is not divisible by 3. So 26 is not divisible by 3. 45. 4 plus 5 is 9. 9 is divisible by 3. 15 is divisible by 3. 84 is divisible by 3. How many numbers are two-digit numbers that are divisible by 3? 3 of them. Don't forget the 84. That's going to be the number one error that people make. They are going to look and say, oh my goodness, B is numbers divisible by 3, especially if they label it for you. And C is two-digit numbers. So where they intersect is right here. The intersection point is right here. So that must be it. Don't forget that extra little 84 that also falls under B and C, even though it also falls under A. Does that make sense? All right, let's keep going into the next problem. I think we are done with Venn diagrams for today. That was a lot of Venn diagrams, but sometimes I like to just really explore something all at once because it allows all of us, elementary through high school, to really understand that concept. So let's go into a little bit of elementary geometry. A teacher has her students practicing representing shapes on a geoboard. A geoboard is just one of those like pegboards. So it looks something like this, and these are all little pegs that are sticking out the top of it. And kids can wrap their rubber bands around these pegs so it would look something like this. Like if the teacher said create a triangle, it would look something like this if they wrapped their rubber band around it, right? So a child uses his rubber band to create a 6-sided shape. What shape did the child create? Well, 6-sided shape. If we are taking the pre-K through 3 or the elementary math assessment, we have to understand what our shapes are, right? And it seems like a silly thing for me to be saying, but under the pressure of a test and looking at all these words, you would be surprised that there are a lot of people that would get this question wrong because the pressure of the test is just a lot. So 6-sided is hexagon because they both have that x sound. Pentagon is 5. hexagon is 6, and those are the most common ones people mistake. People often flip pentagon and hexagon, but if you can remember hex, 6, you will be golden. Nonagon is 9, and octagon is 8. So in this case, the student created a hexagon. And there's a lot of different ways that hexagon could look with their rubber band, but just know the child created a hexagon. We don't need to know what that hexagon looks like on that geoboard, right? All right. Next question. We have time for 2 more. Which of the following sets of shapes is similar? Here's what now, most common error, people are going to pick B. But similar is not the same as congruent. Now, elementary people, this is what similar and congruent would look like on your test. Middle school and high school people, similar and congruent is going to be you finding the pieces and parts of a similar or congruent shape, right? So, A, not similar, not congruent. Similar means I took a shape and I stretched it proportionally so that they have a similar proportion. They have a proportion that is equitable, but they are not the same size. Yes, Milagros, you're absolutely correct. So this is not similar because this is not the same. These are congruent because they are the exact same shape, the exact same size. These are similar because we took a small shape and we stretched it proportionally and created a larger version. These are also congruent. Just because this one is turned doesn't mean they're not the same. That would be like me taking a piece of paper and then taking another piece of paper and turning it and saying, are these the same? Well, of course they're the same. They're both white pieces of 8.5 by 11. Just because I turn it doesn't mean it's not the same. So that's what happened in D. All right, last problem of the night. Jocelyn has a box that she wants to paint. The box is a right triangular prism in which the right triangle has a hypotenuse of 17 inches and a base of 8 inches. The prism has a height of 20 inches. What is the surface area of the prism? What are we looking for when we're looking for surface area? We're looking for the amount of space that we can paint. We are not looking at how much water can go in the bottle. We're looking at how much paint can cover the bottle. 2 different things. So I'm going to draw my right triangular prism. And I'm going to label it. A hypotenuse of 17 and a base of 8. And the prism has a height of 20. That is not that value. The height of a prism is the length or the distance between my 2 bases. And I know the bases are my triangles because it's called a right triangular prism. So this is 20. Now, when I think of surface area, I'm thinking of the area of all the flat shapes in this shape. So I've got 2 identical triangles, congruent triangles. And then I have 3 rectangles that I need to add. All of the rectangles have the same length. So they're all going to be 20. But their heights or their widths are going to be different. this for this rectangle is not going to be the same as this for this back rectangle or this for this bottom rectangle. So I know one of them is going to be 8, one of them is going to be 17, and I need to find the other one. Well, I can start with 8 times 20 and 17 times 20. 8 times 20 is 160. 17 times 20 is 340. Now, I need to find that missing side of that right triangle before I can do anything else, because it's going to determine the area of my triangle and the width of my missing rectangle. How do I find the missing side of a right triangle? A squared plus b squared equals c squared. Pythagorean theorem. So the hypotenuse is always going to be c. So I have a squared plus 8 squared equals 17 squared. A squared plus 64 equals 17 squared, which is 289. Subtract 64 from both sides, and we get a squared equals 225, square root both sides, and a equals 15. That's amazing, because now I know that this is 15 right at the end. We were so close. Pythagorean theorem is not going to find our area. Area of a triangle is 1/2 base times height, right? So if area of a triangle is 1/2 base times height, then Pythagorean theorem tells me the missing side of a triangle, okay? So much to remember, I know. So 15 times 20 is 300. And now I can find the area of my triangle. 1/2 base times height, 1/2 times 8 times 15 is 60, but I have 2 of them. Now, when I add all of those up, I get 160 plus 340 plus 300 plus 120 equals 920. Man, I feel like that problem I speeded through. If there is anything I went over tonight that you are questioning, you're not sure, or I didn't go over something that you're like, man, I really wish she would have gone over X, Y, or Z, let me know in the comment box or shoot me an email. I gave my email at the beginning. Shoot me an email or let me know in the comment box what you need help with moving forward so that I can cater our Wednesday night sessions to you, because that's what best serves you. So I'm going to turn it back over to Dr. A. He has a special code for you. I will see you guys next week. But all of that said, let me know what you'd like to see. Otherwise, we'll just keep rocking and rolling with random math problems. Yes, that's exactly why I circled it, Milagros. Good. All right. See y'all next week.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. but this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SYNC35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.